Hey, we're back again with Team 2073 Eagle Force, talking with their driver Ali and their programmer Jason about the unique control system. I've seen steering wheels before that other teams have used, and I've been like always super interested, and I haven't really gotten a good chance to see like how they work or like how it feels to drive them. But I'd love to talk a little bit about the code behind it and about like how it feels to drive it.
So yeah, using a steering wheel, it kind of changes the way we do the driving a bit. So, you know, we use the steering wheel because the more open field, we have to do big arcing turns. So we have a couple pieces of specialized code that we group into a system that we call Eagle Drive. Mm-hmm. So basically what that consists of is inverse inertia, which when we start a turn, will modify how the power is going to different motors rather than just being straight linear, you know, minus from this side, add to this side. Mm-hmm. It will give additional power to your turning side and subtract from the other side. So it helps a faster turn, and plus we have dropped center wheels, so we really just whip around. So that's much better, and then it does the opposite of that when we're coming out of a turn. So that helps us maneuver around the field a lot better. Another one of the programs within Eagle Drive is, we just call it Eagle Drive. There's not really a certain name for it. What it does is it is a system of equations where it's linear within a certain area of your power. So when you're going to place a gear and doing fine motions, we go into low gear mode, which is about 6 feet per second. But then we have really fine control for, okay, if you need to pick up, there's a gear underneath balls. You have to be really careful so you don't get anything jammed. Right. So we can use something like that. But when we go to higher speeds, it's a cubic equation, so to the third power. Wow. So it can get a little tricky, but what that allows us to do is accelerate, use the full potential of all of our hardware, so we're not wasting any of what we use our weight on.
I've seen teams use a exponential drive system before, where it's like kind of like really fine-tuning low, and then up at the high end of the stick, it's like really like high gain. But like having it like linear to a point, does it switch over at a certain point of power?
Yeah, there's a point. So it's about where it gets too fast to control easily. Mm-hmm. So I mean, it's really up to preference. So we just kind of tune it with the driver and stuff. So
gotcha.
So do you want to talk about it?
Yeah. So talk a bit. So you said you used like 2 joysticks last year. It's kind of a standard drive system. So I'd like to talk about like kind of the difference with the steering wheel and how you think of like the benefits of it on the field, and also about like fine tuning it with the code, about like how you can kind of like tune the preferences to your kind of like feel for it.
Yeah, so in past years we've switched between steering wheels and tank drive using 2 joysticks. It largely depends on the game because I'm comfortable with both driving systems, but a game like this where you have the unique challenge of having both a wide open field and those tight constricted spots where you have to have those fine movements. So a steering wheel is great for wide open fields and fast robots. It gives you greater control, wider turns, little bit smoother actions, whereas a tank drive, last year the field was divided into thirds. You didn't go anywhere very quickly. Yeah. So using that gave me much more control. So like I said, this year we just preferred the steering wheel. And like Jason was talking about, I get a lot of the fine controls at the lower speeds, but at the higher speeds, when I have to go across the field quickly and react quickly, it gives me a much faster response time, and it's a lot smoother.
Awesome. Very cool. Thank you guys.
Thank you.